All right, so let's go, right? So in order for us to start the cubic, I just want to go over the quadratic, right? You don't have to write this if you remember everything, right? So if we have ax squared plus bx plus c equal to 0, and alpha and beta are the roots, then the sum of the roots, alpha plus beta, is minus b on a, and the product of the roots, alpha beta, is c on a. And note that generally a quadratic can be written like this: x squared minus the sum of the roots by x plus the product of the roots equal to 0. So generally, these are the things that we need to remember about a quadratic. All right? X squared minus the sum of the roots by x plus the product of the roots is the general form for a quadratic. Everything you see in here, there's the same thing for cubic, right? I'm going to just give it this in case you all forgot. What's alpha squared plus beta squared? Alpha plus beta squared minus 2 alpha beta. Right? The good thing is with all the recent past papers, they gave you these rules, so you don't have to memorize them. Right, so let's try this one here from 2012. In the earlier years, they only had quadratic, they didn't have cubic, right? They recently added the cubic. Let's say we have 4x squared minus 3x plus 1 has the roots, alpha and beta. They want you to find a few things. They would like you to find alpha plus beta and alpha by beta. Second thing, they want you to find alpha squared plus beta squared. And third thing, that's probably the hardest part, find quadratic. Right? Take your time, find each part, and then let's work it out, right? All right, so let's see. So the first part, alpha plus beta minus b on a, so that's 3/4. Alpha by beta, that's c on a, so that's 1/4. Alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. So that's 9 on 16 minus a half. So that's 1 on 16. Next, to get the equation is generally of the form alpha squared minus the sum of the roots by x plus the product of the roots. So you have to simplify this out, right? So let's work out this first. When you find the LCM, you'll get alpha squared beta squared, and on top, you'll get 2 alpha squared plus 2 beta squared that you can easily work out, right? So that'll be 2 by alpha squared plus beta squared. We just work out that. So that's 2 by 1 on 16. Alpha squared by beta squared is 1 on 4 squared. 2 on 16 over 16, 2. And then this one here is 4 over alpha squared beta squared. So that's 4 over alpha squared beta squared is 1 on 4 squared. What is that? 16 by 4, 64. So the final answer is x squared minus 2x plus 64. All right, so just a quick review on what we did before. All right, so let's take a look at cubic equation. All right, so the general form of a cubic is ax cubed plus bx squared plus cx plus d is equal to 0. All right, that is the general form for a cubic equation, right? And if alpha, beta, and gamma are the roots of then alpha plus beta plus gamma, that is called the sum of your roots. The sum of the roots is minus b on a. All right? Watch this here. What is also doing, I want you to understand how they came up with the pairwise sum. If you have two roots, right? And you want to find the pairwise sum, what it means is that you're pairing them up. So you're pairing alpha with beta, pairing alpha with gamma, and you're pairing beta with gamma. And then you're adding them up. That is called a pairwise sum. So if you see I use the term pairwise sum, all it simply means is just pairing up the roots and adding them up. Alpha by beta, alpha by gamma, and then beta by gamma. That's equal to C on E. And last one is product. Product is alpha, beta, gamma, which is minus D on E. Okay? The last thing is we have to also be able to write the general form, right? Make a mistake here. Take off the equal to 0. Right? So the general form when equal to 0 is as follows, right? X cubed minus the sum of the roots by x squared plus the pairwise sum by x minus the product of the roots. All right? So x cubed minus the sum of the roots by x squared plus the pairwise sum of the root x by minus product. Right, for the first one, I got 5 on 2. Next one, I got positive 2. And the last, I got minus 3. Right, in order for you to simplify part 4, you have to find the LCM. Alpha, beta, gamma underneath, and on top will be alpha, beta, alpha, gamma, beta, gamma. So the underneath is minus 3 and top is 2. Right, sometimes they ask you to find alpha squared plus beta squared plus gamma squared. So that's alpha plus beta plus gamma all squared minus of 2 alpha beta, beta gamma plus gamma alpha. And then in case they ask you alpha beta squared plus beta gamma squared plus gamma alpha squared, that will be alpha beta plus beta gamma plus gamma alpha squared minus of 2 alpha beta alpha plus beta plus gamma. Right, so they will give you this in exam most of the times, but this is not exam, so you have to learn it. Right, so we're going to apply them here. All right, so try this here. Using that cubic, find all those things. Right, so A is 1, B is 0, C is 4, D is minus 3. So the sum of the roots will be minus B on A, that's 0. Pairwise sum, C on A, so that'll be 4. Product, that'll be minus 3 on A, so that'll be positive 3. Remember, there is no squared term, right? So B is 0. A is 1, B is 0, C is 4, and D is minus 3. Well, you'll have to simplify it, sir. Then you could use the formula, sir. What will the numerator be, sir? well, alpha squared, well, ideally to be beta squared, gamma squared, right? But the numerator will be alpha squared, beta squared, alpha squared, gamma squared, and the beta squared, gamma squared. Now we could use the formula I gave you, right? The denominator is plus 3 squared, right? The next one will be the pairwise sum squared minus 2 by the product by the sum. Sorry, this is 0, right? By the sum. So I have 16 on 9. Next one is what? Next one is alpha squared, beta squared, gamma squared. And numerator is alpha squared, beta squared, gamma squared. So again, the underneath is 9. And the numerator is what? Alpha plus beta plus gamma all squared minus 2 by the pairwise sum is 4. So I got minus 8 on 9. And then the last one is 1 over the product, 1 over 9. Okay? How we get the equation now? X cubed minus the sum of the roots. What's the sum of the roots? We work it out already. 16 on 9, nice job. Plus the pairwise sum. The pairwise sum is what? Pairwise sum is minus 8 on 9. Remember, you're using these new roots now, eh? So the pairwise sum is here. By x minus 1, 9. You can multiply everything by 9 to make it look nice. 9x cubed minus 16x squared minus 8x minus 1 is 0. So that's method 1, and method 1 generally works for all the past paper type questions. Copy it down. I want to show you our next method. All right. So the next method looks like this. Right? Remember, we had the equation x cubed plus 4x, right? Minus 5 is equal to 0. Oh, minus 3. Right? And we need to get a new equation with roots 1 on alpha squared, 1 on beta squared, 1 on gamma squared. So here's how we could do it as well. Our next way to do it is something like this. So remember alpha squared and beta squared and gamma squared, right? Remember, those are the x values. All right? Technically, those are the x values. So technically, we have 1 on x squared. All right? And 1 on x squared, let's make it equal to some new letter. Let's call it letter u. Right? Let u equal to 1 on x squared. So what we need to do is develop a new equation in terms of u now. Okay? So the first thing we're going to try and do is make x a subject of the formula. So I can replace all these x's here in terms of u. So x squared is equal to 1 on u, which implies x will be the square root of 1 on u. So x is really 1 over u to the power of a half. So what would x cubed be? 1 over u to the power of, cube everything, right? So it'll be 1 over u to the power of 3 on 2. So if I substitute now in x cubed plus 4x minus 3 is 0, I will end up with 1 over u to the 3 on 2 plus 4 by 1 over u to the half minus 3 is 0. But of course, kind of looking like what we have, right? So let's try and remove the denominator. So let's multiply everything by u to the power of 3 on 2. You'll be left with 1 plus 4 by, what is u to the 3 on 2 divided by u to the half? And that'll be 3 on 2 minus a half, which is 2 on 2, which is 1. Yeah? So you'll end up with 4 by u minus 3 by u to the 3 on 2 is equal to 0. Trying to make it look nice, right? So we have 1 plus 4u is equal to 3u to the 3 on 2. So I'm going to square up here, and I'm going to square up here so I don't have that fraction anymore. So here I'll get 1 plus 16u squared plus 8u. Right? That's when I expanded the bracket there. Is equal to, I'm going to square the right-hand side, and I will get 9u cubed. Now bringing everything on your left side, I'll get 9u cubed minus 16u squared minus 8u minus 1 is 0. Right? So the new equation is, I just changing the u back to x, right? 9x cubed minus 16x squared minus 8x. Same thing as before. Yeah? All right, so that's the next method, which you don't have to use because they'll give you all the formulae. But if in a question they don't give you like what is alpha squared plus beta squared, and you don't remember, use this method. It will always be u equal to whatever the root is. And then from there, you find what is x. I'm going to give you one here, but I want you to use method 2 alone. X cubed plus 5x plus 2 equal to 0 has roots alpha, beta, and gamma. Find an equation whose roots are 1 on alpha, 1 on beta, 1 on gamma. Alpha, beta, and gamma, since they are the same basically form, then that means x could be alpha, x could be beta, x could be gamma. So that new root u is 1 on x. Let's see what you got. U is equal to 1 on x. So therefore, x is equal to 1 on u, which also means that x cubed is equal to 1 on u cubed. So when I substitute now, when I substitute in x cubed plus 5x plus 2, I will get 1 on u cubed plus 5 by 1 on u plus 2 is 0. Multiply everything by u cubed, you'll get 1 plus 5u squared plus 2u cubed is equal to 0. Rearrange it, you'll get 2u cubed plus 5u squared plus 1 is 0. Right? And then you could do your replacing, and you will get your equation as 2x cubed plus 5x squared plus 1 is 0. All right, so let's start here. I think this is 2022, right? They didn't specify a method, but they gave it some values, right? So x is equal to 1 on u, right? Or technically u is equal to 1 on x. So x is 1 on u. So x squared is 1 on u squared. X cubed is 1 on u cubed, and so on, right? Well, that's all we need, right? So I'm going to substitute in equation 1 here. So I'll get 2 by 1 on u cubed minus 1 on u squared plus 3 by 1 on u minus 1 is 0. So I'll get 2 on u cubed minus 1 on u squared plus 3 on u minus 1 is 0. Right? Multiply everything by u cubed. So you'll get 2 minus u plus 3u squared minus u cubed is 0. You could rearrange it, and you'll get positive u cubed minus 3u squared plus u minus 2 is 0. And then you could replace with x. So you'll get x cubed minus 3x squared plus x minus 2 is 0. Try this fast. That's the main and factor, right? Let's see what you got. Right? So if something divisible by 1, it means f of 1 is 0. If the remainder is 6, it means that f of minus 1 is minus 6. Right? Those are the remainder and factor rules. So when I plug in 1 in here, I'll get 2 minus p plus q minus 10 is 0. So I get in minus p plus q is equal to positive 8. The second equation is for minus 1, so that'll be minus 2 minus p minus q minus 10 is minus 6. So minus p minus q is equal to minus 12, positive 12, positive 6. Now we're going to take equation 1 and 2 and add them. Positive p is 14 on minus 2, so that's minus 7. And q is equal to minus p minus 6. So that's 7 minus 6, which is 1. Q is equal to 1. Right? Let's go again. Let's go to B. Do you think? What are looking like? Some kind of quadratic, right? Some kind of disguised quadratic. Just to show you the substitution, right? You could let y equal to 2 to the 2x. Remember that 4 to the 2x is the same as 2 squared to 2x. Because it's multiplication, we can switch it around. These two things are the same, right? And remember, this is y, right? So we'll get y squared. All right, so we should get what? We should get 6 minus 7 over y minus 3 over y squared is 0. You can multiply everything by y squared, and you'll get 6y squared minus 7y minus 3 is 0. When you solve it, you'll get y is how much? Minus 1 over 3. Remember, y is really 2 to the 2x. 2 to the 2x is minus 1/3. This has no solution. That has no solution, right? Now you want to get 2 to the 2x is 3 on 2. Take logs on both sides. You'll get 2x is equal to log 3 on 2 all over log 2. And you'll get 0.9. Amanda got 0.292. Right? Let's go again. Let's check this out now. Y is equal to 3x plus 1 on x. Interchange x on y. X on 1 is equal to 3y plus 1 over y. Cross multiply and solve for y, right? So you'll get 3y plus 1 is equal to xy. Bring all the y's together. And then make y the subject. So y is equal to 1 over 3 minus x. Oh, sorry, when I carry it across, this is minus 1. Which is the same as 1 over x minus 3. That's okay. The next one is a composite function. Real easy. You want f inverse of g of x. Right? So the first thing you do is write what g of x is. G of x is e to the minus 2x plus 1. So all we're going to do is plug in this in f inverse. So that'll be 1 over e to the minus 2x plus 1 minus 3. So the answer is 1 over e to the minus 2x minus 2. So all you're doing is just plugging in e to the minus 2x plus 1 into f inverse. Yeah, man, look a little modulus here. Yeah, modulus, then logs. This is number 1C now. Right, so when 3x plus 2 is more than 0, then you will get positive 3x plus 2 is more than or equal to 4. 3x plus 2. 3x is more than 2. X is more than or equal to 2/3. When 3x plus 2 is less than 0, then we use the minus in front. Right? Carry across the minus sign. If you want, it's up to you. You can leave it here. Carry across the minus 2. You'll get positive 6. Now, when you divide everything by -3, the inequality sign will change. So you'll get x is less than -2, but x is more than 2/3. So x is less than -2 together with x is more than or equal to 2/3. All right, last one, the logs, and we're done. Right, so apply the rules quickly. Log 5, addition means multiply. And 1 is really log 5. Right, chop off the logs. X plus 2 by x plus 6 is equal to 5. So x squared plus 8x plus 12 minus 5 is 0. X squared plus 8x plus 7 is 0. X plus 7, x plus 1. So you get x is -1 and -7. Right, so the answer is no valid solution. Right, actually -1 could work in this question. You know, when I get negative values, there's no solution, right? If you put -7 in here, it wouldn't work because you'd have to find log of a negative value. But if you plug -1 in there, it will work, right? So I shouldn't say no valid solution, right? I should say only this one not valid. -1 could work in that equation. Okay, that brings us to the end of module 1.